In this video, we're going to do collision detection. The player that you see on the screen cannot walk into the water, and they also can't run into trees as well. So let's get started. The big thing we're trying to accomplish here in this video is to determine if two rectangles are colliding with one another. If you have this rectangle and it's moving along and all of a sudden it collides with the other one, we want to prevent that from happening. The other thing we want to do is that we also have tiles too as well that may be like water or whatever, and we want to make it so that if that rectangle is inside of one of those water tiles, that it can't move there. So if you have a rectangle that's like really big, you're probably going to check a lot of tiles to see that happen. Whereas if you have a really small rectangle, you can see with something like this, we're probably going to only check about 4 tiles. Create a Python file called physics.py. And inside of this, so I'll say from Pygame import rect. Okay. We're going to create a class called body, and this is going to be our component for physics-based stuff. So we'll come in here, we'll do class body, create a constructor. And to make this nice and easy, we're going to use optional parameters. So we'll use x equals 0, y equals 0, width equals 32, and height defaults to 32 as well. These are just default values that we can do. That way we can be lazy and just create a new body and set them later if we want, or we can specify them when you create it. Let's create a hitbox object. And this will simply just be a rectangle where we pass these into it. Now, another thing too, when you're doing physics, like collision detection, you really need to keep track of all the bodies. And then they're gonna, when you want to validate a position or when you want to check something, you basically check it against everything else. So if there's, let's say that there's 10 solid objects and this one solid object moves, you can then check all the other 9, to see if it's colliding with any of those. Let's come up here and we'll create a list of bodies. And then inside of the constructor, we'll come in here and we'll say bodies.append self. And that way we can just keep track of everything. Okay, let's get to the actual meat of collision detection. So go ahead and do is a new method is colliding with self and other. So this is us, like this is the body that you're currently checking. And then the other body, like, so you're checking to see if 2 things are colliding with each other. Then from here, what we'll do is to simplify this, we'll get self entity x plus self hitbox x. So the hitbox is relative, right? The hitbox may be, a little bit into the sprite, like it may not, or it may be a little bit into where the entity is. For example, the player takes up a piece of space, but maybe we only want to check the feet of the player. Or maybe we only want to check like the legs of the player or something like that. So the hitbox is somewhat relative to where the feet are on the player, plus where the player is actually standing. Okay, so we'll come in here and we'll do self entity y. So we'll just do the other direction, hitbox y. Let's do the same thing with the other entity. So we'll come in here, other x equals other entity x plus self hitbox x. Other y equals other entity y plus other hitbox y. This is really easy to do. Change this right here. I wrote self there. Change that to other. This is really easy to do, especially with these kinds of things. It's so easy to make a little typo or mistake. So I'm actually kind of glad you saw that. Because it happens to me, it happens to everybody. So this is where we actually check if these 2 things are colliding. Now this code, I've actually gotten it from the Mozilla Developer Network, their code that they have on their website. I mean, you can see this is actually a common way of doing it, but I'm just sort of giving credit where it is. They have some really great resources too on this as well. It's written in JavaScript, but either which way, you can, I'll link it in the description below. So let's come in here and we'll do if x less than other x plus other hitbox dot width. So if our left is less than the other's right, so and all of these are going to be kind of like this. We're going to say and use a little slash. This is how we do another line, because this is going to be a really big one. So we'll come in here and we'll do plus self hitbox width greater than other x. So we're kind of checking the other's left if it's if that is less than our right. So and then we'll do y. We just need to do the other direction. So we're going to say less than other y plus other hitbox height and then we'll do y plus self hitbox height other y. This right here checks if two rectangles are colliding with one another. Then we'll come in here and we'll say return true. So we are, else we can say return false. Okay, that's it. That's the meat of doing that. So this is rectangle and rectangle collisions. There's obviously other shapes. There are circle and rectangle, circle and circle. So there's a different function for each one of them. But for this game, we'll just do rectangles. We also want a function that just checks us against all the other bodies, just to make it nice and easy. So we'll come in here and we'll do is position valid self. And that's all it's going to take in. But what it's going to do is it's going to compare itself to everything else and to see if it's colliding with anything. So we can come in here and loop through all of the bodies that we kept track of earlier. And then we can come in here and we can say if body does not equal self. We want to make sure we're not comparing ourselves to it. This is a common thing. If you code physics, I've done this so many times. If you code physics and then it's like, wait, it's like it can't even move. It's not do this, right? Just make sure that you're not checking yourself. And body is colliding with self. If this is the case, we return false. The position is not valid. We found a collision. And we can just return false. Like the moment we find one, it's over. Like we don't have to check anymore. Otherwise, we're going to do return true. Okay, there we go. At the moment, the only place that we need to do collision detection is the player class. Obviously, we're going to probably add stuff later on, like, the enemies, collision detection or whatever. But let's go to the player class and let's go ahead and import our body class. So from physics, import body. So one way we can do this is we can just store the previous position, and then if we hit a collision of some sort, we just roll back. We just go back to the previous. So let's get the previous x equals self entity x, and we'll do previous y, if I can spell, equals self entity y. So now we have the current position. Another thing we need to get is the body. So we're going to say body equals self entity.get body. And there we go. And this is one of the reasons why entity components are so nice, is we can just be like, hey, just get the body, and we've got it. Okay, so let's come in here, and the way I like to do this, or a really simple way to start out at first, is you can check for when the player moves up and down, and then check if when the player moves left and right independently. So you actually do two checks, and the reason for this is that maybe you ran into a wall, and that's okay, but you want to allow the player to continue to move left or right. If let's say they collided it from the top, you want them to be able to move left or right. Similarly, if you collided, from up and left and right, you still want them to be able to move up and down. So let's come in here and we'll do this. If not, body is position valid So if the position is not valid, all we do is just roll back. Self entity y equals previous y. That's it. There we go. We'll separate this code. So we're going to do our checks, right? We're going to say if the W key is down, entity y, we're moving up and down. And then, hey, if the position is not valid, just go back. We'll do the same thing for X too as well. We'll come in here, if not body is position valid, self entity X, previous X. That's it. Cool. So if we move to left and right, and then the position is not valid, just roll back to the previous X. So let's come into main.py, and we'll import our, so we'll say from physics, import body. So we'll import our body class. Then we'll come down to the player, and on the player, we're going to add a body. And we can actually do it here or wherever, just, you know, before these things. So we'll say body, and I have a couple values that correlate with the location of the player. I'll just kind of show you real quick. So if you look at the player, or at least this one right here, you're going to go like maybe a couple pixels to the left, and then you're going to go several pixels down. And I have a couple values that we can use to kind of start out with. And then the size of the feet is kind of like this width, and then this height. Let's come back to main.py. And we'll come in here and maybe we'll go 8 to the right, and we'll do 48 down, and then we'll do 16 left and right is the size of the hitbox, and then we'll do another 16 for the size of the hitbox as well. Cool. And then we just need to do a comma, and we're good to, yeah, perfect. We're good to go. Cool. So we have this. Now we just need to add a body to the tree as well. So we'll come in here, and we'll say body. And if we look at the tree, taking a look at this, really we should only be kind of checking the stump. On the tree, we'll go ahead and say, let's do the same thing. The tree is 64 by, yeah, so we need to do a little bit more. So we'll come in here, maybe 16, and then we'll go 96 down, and then maybe we'll do 32, and we'll do 32 as well, because it's 128 in total. So I think this should get us close, and you can kind of tweak it to your liking. But yeah, let's go ahead and do, let's jump into main.py and we'll run it. And if we use the player can now, yeah, the rendering is a little interesting. We're gonna have to kind of fix that, but yeah, there we go. Yeah, so the player is now not able to walk into trees, but they can walk around them. Right, we don't want to, we want the collision box to only be checking the feet and the stump. If you get that, it works. Perfect. The last thing that we need to do is we need to, if we're running the game, we need to make it so that maybe water is solid too, so that they can, yeah, let's do that. So let's come in here, and one thing, in your main.py, find the water tile. If you have other ones, you can just change those as, you know, well. And we're going to say true. This means solid. So it basically means that you can't walk through that tile. Let's now go into our map file, and we'll go from there. We're going to check if rectangles are solid, and we're also going to check if a point on the map is solid. So create a function is point solid. Self. X and Y. And then we'll do paths. And then we'll do another one is rectangle solid. Self, X, Y, width, and height. And we'll do paths. Let's jump into the is point solid. We need to know which tile we're on, like X and Y of those coordinates. So we can come in here, we're gonna say X tile equals int X divided by self tile size. Dividing by however big the tiles are. So if we're at like 30, if we're at 64, we divide it. Okay, now we're 2 tiles to the right. And then we convert it to an integer that throws away the decimal place. And then we have what tile that we're at, left and right. We'll come in here, we'll do the same thing for Y, self tile size, and we'll go from there. Next thing, we need to actually check if the tile, like we may not even be standing on the map. And if you try to access a tile that's like outside of the map, you could actually crash the program because it's like out of bounds. So let's check that first. Let's say if x tile is less than 0, or we'll use our things that we did earlier, y tile less than 0, or we'll say x tile greater than or equal to the length of self.tiles. So the rows, right? Self.tiles is a bunch of rows. Ooh, this should be y. Change this last one that we did to y. And we'll go from there. Okay. Or x tile greater than or equal to length. What? You saw that. Tiles, y tile, colon, and then return false. Okay. Then we'll come in here. If we're inside of the tiles, so if we get to this point, we're inside of the tiles. We'll come in here and do tile equals self tiles, and then y tile and x tile. So whichever one that we're on. We have the current tile, and we're going to return self.tileKinds tile. So we're looking it up, like is it grass, is it dirt, whatever, and then is solid, whether grass is solid or whether water is solid or whatever. Let's finish this up by doing our is rectangle solid function. So this, as opposed to just checking one single point on the map, it could potentially check multiple points. So you're going to kind of spread out the checks, and if any one of those fail, then it will just say, oh no, this rectangle, there's a solid point at this rectangle. So let's go ahead and see. The checks are going to be sort of two-dimensional. If, for example, you have a 32 by 32, you might do 4 checks on each one of the corners. Or if you have 64 by 64, you might do like each one of the corners and then checks in the middle too as well. So it might be 3 by 3, so 9 checks in total to do that. So and then obviously the bigger the object is, the more that you're checking in order to, you know, check each tile that the object is currently on to see if any of them are solid. So let's come in here and we'll see how many we need to do in the x direction. So we'll say the following. We'll do this, and okay, perfect. There we go. We're dividing it. We're like getting the width, like how big is this thing divided by the tiles, and then just, yeah, we're getting an integer of that. So that'll tell us how many times we're checking. Do the same thing for the y direction. So we'll come in here, seal, and we'll do height, self tile size. Perfect. We need to import seal, but we'll do that in a second. All right, so let's loop through two-dimensionally. So we'll say I, y. We already have a variable called y, so we need to do y, and then we'll do in range x checks, so however many we have, and for xi in range x checks, and we'll go from there. Be very, very careful. I hope you saw it. I just made a mistake. Take a look at this right here. This should be a y. This is so easy to do. It's so easy to mix up x and y. So just be careful as you're kind of going through that. I'm glad you saw me mess up on that. All right, so we'll come in here and we'll do x equals xi times self tile size plus x. So we're doing like 0, 32, 64, 96. We're like kind of just stepping in that direction. And then we'll do y equals yi times self tile size plus y. Okay. And then we'll do, let's check if the is point solid, x and y, and then we'll return true. If we hit something, we'll return true. Okay. We're also going to check, this will check everything in the middle and the very top left corner, but we also need to check the other corners as well. So we'll do separate checks for that. We'll say if self is point solid, x plus width, so the very corner, y, and then we'll do return true. Okay, so that right there is the top right corner. Now let's check the the left bottom corner. So we'll say is point solid, and we'll say x, y plus height, return true. And then we need to check the right bottom corner. So we'll say if self is point solid, x plus width, y plus height. Again, all the code is in the link in the description below. So if you get stuck at any point, you know, no worries. It can happen, absolutely. So, yeah. Okay, so then if none of those were the case, we're going to return false. Like, oh, no, you're good to go. It's not solid. Let's import the ceil function real quick, the ceiling function. Go up to the top, and we're going to say from math, import ceil. So now we need to bring this code together. And I think we should make the map a singleton, meaning that there's only one of those in the entire application, and essentially anything can reference that one map. I think that makes logical sense because the map handles all the tiles and everything. So we should be able to sort of access it anywhere. So go up to the top and let's go ahead and say map equals none. So it's going to start out as nothing. So you have to create a map before you get one. And then inside of map, we're going to come in here and say map equals self. So we're going to set the current value to that. One last thing we need to do is we need to say global map. We need to take in this global variable that's up here and then set it equal to that. Singletons are kind of a controversial thing in programming. Some people don't like using them. Other people really like using them. It gives you a lot of power because you can reference it anywhere. But you know, a word of caution, that also comes with a lot of responsibility. So you know, you need to treat the map, you know, basically correctly and not corrupt it or, you know, set this to some other value or whichever. So now that we've done this, let's come into physics. We're going to come into the is position valid, and we're going to say from map import map lowercase, the variable that we created, not the class. Let's get the current x position. So we'll do self entity x plus self hitbox x. Kind of what we were doing, the same thing here. Y entity y plus self hitbox y. Cool, because again, the hitbox is relative. And so now we'll say if map is rectangle solid, x and y. We also need to pass in the width and height. So we'll say self hitbox width and self hitbox height. If this is the case, we're going to return false. That's it. We just add an additional check here to, you know, that, and then we check the bodies after that. And then if everything's good, then we return true. Let's go ahead and test this. So we'll jump into main.py and let's go ahead and run our code. And yeah, the player can now walk around and they cannot walk on water. Honestly, this was quite a bit of code, and if you made it this far, excellent job. We now have an adventure game where the tiles are solid, and also the you know, things like the trees and stuff are solid. And now you technically could, like if you wanted to make a maze out of this, or, you know, start really building out your world and doing that, you know, absolutely. But thank you so much for watching. I hope you enjoyed this video, and I hope you have a good rest of your day.